Let's get right to it. You often hear me talk about applied knowledge versus theoretical knowledge. What's the difference? My youngest son is 11. He loves cars. He knows a lot about them. He's been on four-wheelers, go-karts, and motorcycles. He knows a great deal about how internal combustion engines work, more than I do, thanks to YouTube. Therefore, his theoretical knowledge of cars is far greater than mine. With that said, he's never driven a car. His knowledge about driving is all theoretical. How would you like it if I came to your neighborhood, handed him the keys to my SUV, and then let him drive around a little bit? If you're sane, I'm guessing you'd rather not be around when I do that. That's exactly how I feel when I must work with someone who has a master's and a PhD and no applied experience. Their knowledge is from books. It's all theory. They know the theory, but they have no idea how to apply it in the real world. Let's take a more real-world example. All of us who have taken a basic statistics course know what an outlier is. An outlier is a data point that's noticeably different from the rest. It represents an error in measurement, maybe bad data collection, or simply a show of variables not considered when collecting data. Knowing what an outlier is for machine learning isn't good enough. You're going to need to know how to deal with them. So, in an interview, after I ask a candidate what an outlier is, I ask them what are common ways to deal with it in Python for machine learning. Let's watch this lesson from my course on data cleansing. It will show you what I mean. Before we look at outlier identification methods, let's define a data set we can use to test our methods. We're going to generate a population of 10,000 random numbers drawn from a Gaussian distribution with a mean of 50 and a standard deviation of 5. Numbers drawn from a Gaussian distribution will have outliers. That is, by virtue of the distribution itself, there will be a few values a long way from the mean, rare values that we can easily identify as outliers. We're going to use the rand_n function to generate random Gaussian values with a mean of 0 and a standard deviation of 1. Then we're going to multiply that by our results, then multiply the results by our own standard deviation, and add the mean to shift the values into the preferred range. The pseudo-random number generator is seeded to ensure that we use the same samples each time we run the code. So the first approach we're going to look at is called the standard deviation method. If we know that the distribution of values in the sample is Gaussian or Gaussian-like, we can use the standard deviation of the sample as a cutoff for identifying outliers. The Gaussian distribution has the property that the standard deviation from the mean can be used reliably to summarize the percentage of values in the sample. For example, within one standard deviation of the mean, it's going to cover 68% of the data. So, if the mean is 50 and the standard deviation is 5, as in our test set, then all the data in the sample between 45 and 55 will account for about 68% of the data in the sample. We can cover more data in the sample if we expand our range as follows. One standard deviation from the mean is 68%. Two standard deviations from the mean is 95%, and three standard deviations from the mean is 99.7%. A value that falls outside three standard deviations is part of the distribution, but it's an unlikely or rare event, and it's approximately a 1 in 370 sample. Three standard deviations from a mean is a common cutoff in practice for identifying outliers in a Gaussian or Gaussian-like distribution. For smaller samples of data, perhaps a value of 2 standard deviations, which is 95%, can be used. And for larger samples, perhaps a value of 4 standard deviations, which is 99.9%, can be used. All right, let's put all this together in an example. Sometimes the data is standardized first, i.e. to a z-score with a 0 mean and a univariance, so that outlier detection can be performed using standard z-score cutoff values. This is a convenience and it's not required in general. All right, we're going to calculate the mean and standard deviation of a given sample, then calculate the cutoff for identifying outliers as more than 3 standard deviations from that mean. We can then identify outliers as those examples that fall outside the defined lower and upper limits. Alternatively, we can filter out those values from the sample that are not within the defined limits. All right, let's put all this together. We're going to use the sample data set we generated earlier. Running our code, we'll first print out the number of identified outliers and then the number of observations that are not outliers, demonstrated on how to identify and filter outliers respectively. So far, we've only talked about univariate data with a Gaussian distribution, i.e. single variables. You can use the same approach if you have multivariate data, i.e. data with multiple variables, each with a Gaussian distribution. In conclusion, it's not enough to have a theoretical background in machine learning. You're going to need to have some real-world experience. You're going to need to know how to apply the knowledge, or most companies simply don't want you. If they wanted a statistician, they would have hired one. They don't. They want machine learning engineers with applied knowledge, not just theory of the subject. Thanks for watching. Don't forget to like and subscribe. and have a great day. We'll see you soon.